index location if the first one is free. If the first index slot is be empty, then we can able to insert by incrementing the rear pointer variable at the initial index value. Okay, means the front and rear both pointer variables they can able to rotate in a circular fashion. Okay, there is for inserting element or deleting the element. Okay, there is no end or there is no starting point. Even though you have the index starts from 0 to n-1, you can able to perform insertion on every slot in a n number of times. Okay, whatever the element you are inserting at one index location, if it is deleted by the front in the sense, okay, in a circular way, again if you come back to the same index location and if it is free, you can able to insert the data. Okay, so as it is in the circular, you can able to rotate, you can able to move, or you can able to traverse, okay, in a circular way, and you can able to use the particular index and the location what it is showing by the index in n number of times. Am I clear? And most important thing is, as we already know that if you are going to insert the data elements, as we already know that we are going to depends upon the rear pointer variable. And if you want to delete the elements from the circular queue also, you can able to depends upon the front pointer variable. Okay, and the difference between a normal linear queue and the circular queue, one more difference is the formula. Okay, if you are going for the normal queue, the rear equal to rear plus 1. But here in the circular queue, the equations given for the rear and front are both changed. Rear equal to rear mod length plus 1 and front equal to front mod length plus 1. So that the rear can able to show you a new location, there you can able to insert. Similarly, the front can able to delete the element from the circular queue. So this is all the algorithms in Q algorithm and DQ algorithm. Okay, where see now the front is equal to front mod length plus 1. Okay, similarly rear equal to rear mod length plus 1. So that is the only equation we can able to change from the normal queue, a linear queue, to the circular. Okay, and one more thing, if you want to try to insert the element onto a queue, make sure you have to verify the overflow situation. Okay, similarly, if you want to perform DQ, deleting the elements from the queue, either it may be a normal queue or it may be a circular queue, these points are most important. If you want to delete the element from the circular queue also, make sure the queue should not be empty. If the circular queue is empty, we can't be able to delete any element. Hence, you can able to declare that as a underflow situation. Okay, so all these about the discussion, comparison of linear queue and circular queue, all we completed this in the previous class. Okay, now we are going to be left out with the two different types of a queue now. Okay, till now we discuss linear or normal queue, second one is circular queue, and the third one is about the priority queue. Okay, we have two more, one is a priority queue and one more is a DQ. Okay, if you these two concepts are most advanced concepts. No? Again, this priority queue and DQ will be repeated in your 2-1 advanced data structure subject. There we have one unit about priority queue and about DQ. Okay, so up to now, up to for this 1-2 semester, why they are included here is you should aware what is the difference. What is the difference between linear queue, circular queue, and what is the difference with the priority queue and the next upcoming DQ. Okay, in order to make the difference, they included here in the data structure subject only. Okay, but actually these are advanced concepts. In order to implement the priority queue, you have the two different types of data structures. Okay, max heap and min heap. Okay, those you can able to get in your advanced data structures. Okay, we have the two other data structures called as max heap and min heap. Okay, max heap as well as min heap. There are two different advanced data structures concept. No? Okay, that we will see in the next semester, no problem, in the advanced data structure subject. But till now, up to the data structure subject, you should know what is this priority queue and what is the difference, okay, with the priority queue to the queues what we discussed till now. Okay, so let me explain what is meant by the priority queue. Okay, here the term priority queue is a two terms mode. Okay, first go for what is meant by this priority. Then you obviously should know what is meant by queue. Queue is a linear data structure. Queue is a linear data structure. Then what is this priority queue is? Here the element what we are going to be inserted is based on the rear pointer variable. Similarly, and the element what we are going to be deleted, it is also based on the front. Okay, those are same. But here, every element should contain a priority. Okay, priority means we should assign a numerical value to the every data element what we stored in the queue. Okay, whatever it may be, whatever you are storing in the queue, every data element should be contained a priority number. Okay, so based on the priority number, we are going to delete the particular element from the queue. Okay, that's why the term priority queue is evaluated. Just I am giving the definition what is meant by priority queue. Okay, priority queue is also a queue, okay, which contains the two pointer variables, one is the front and one is the rear. At the rear side you are going to insert the element, at the front side you can able to delete the element. Up to here there is no difference. Up to here there is no difference. But if you want to insert a data element onto the priority queue, again it depends upon the rear based on the incoming values you are inserting. And the year first was the uninserted. Okay, based on the order of arriving of data elements, the rear pointer variable has to be incremented and it is been inserted the data element on the queue. So insertion was a difference every level. But at the time of deleting or at the time of accessing or at the time of removing the data element from the queue, it depends upon the front. It depends upon the front, but the front is not works in a linear way. Front will be works based on the priority of a data element. For example, see now. If you have a queue like this, okay, rear is been incremented for inserting the values. Let us take A, B, C, D. 4 data values are inserted by the rear. So now this is the position of the rear. Okay, and here in the priority queue, every data element should have their own priority number. Just like how we are giving ranking, to the students. Okay, similarly, every data element at the time of insertion only, please understand this point, at the time of insertion or at the time of arrival, we are going to insert a numerical value to it. That numerical value will specify the priority. See, for example, randomly I am giving the numbers. Here A have 5, B have 3, C have 2, okay, and D have 1. D have 1. Okay, here what is meant by these numbers? All these numbers are nothing but the priorities. Okay, just like our ranking numbers. Okay, we are going to give some numbers to the data values what we are inserting in the queue. Okay, you can consider lower the number, highest the priority, or higher the number, highest the number, you can able to consider the low priority. Anyway, you can able to consider. Okay, at this time I am considering that lower the number, I am considering it is a highest priority. Just like our ranking. First rank, these are high priority. Second rank, next priority. Third rank, next priority. Likewise, if you consider lower the number, highest the priority, okay, then we are going to identify the data element which have highest priority. A data element highest priority untadandi. A have a number of 5, B have a number of 3, C have a number of 2. So D, if you observe the D, data element D, 1 second. Yeah, data element D, it have the highest priority because we given a numerical value 1 for D, and you are treating that lower the number, highest the priority, just like our ranking system. So I am going to be consider D has highest priority among all the data elements what we have in the queue. So at the time of deletion, please listen this carefully. At the time of deletion, we are going to bring the friend pointer variable to D. Wherever we have the D. D may be at index 4, D may be at index 5, D may be at index 10, it may be at the last index value. It doesn't concern the index value. We are going to treat the data values priority number. So based on the priority of a data element, the friend has to be incremented every time, and finally it reaches to the data element which have the highest priority. That element we are going to be delete first from the entire queue. Okay. Don't bother actually, sir. Am I clear? So whatever the element which have highest priority, that should be preferred first. Okay, that should be preferred by me in order to delete that first. Am I clear? So in this example, A contain the number 5, B contain number 3, C contain number 2, D contain 1. So we are giving the first rank for the D. Means we are going to delete D first. Okay, then only we will go for the next. Okay, after D, what we are going to be delete? We are going to delete C, because C contain numerical value priority 2. So that should be the deleted next. Okay, after deleting C, now we are going to take B, because it is the next one. After that we will go for A. Here the movement of friend, it can able to go for forward direction and it can able to go for backward direction, because we are depends upon the priority. Not we are going to depends upon the priority for what? For removing or for accessing or for deleting the data elements from the queue. Please understand this point. Insertion ki priority ki sambandham ledamma. Okay, based on the order of arrival, we are depends upon the rear pointer variable, and the rear pointer variable every time is being incremented in the forward direction. Means start from index 0, 1, 2, 3 and so on. You can able to reach the last index value. For the rear, we will not consider the priority. We are considering the order of arrival. Okay, order of arriving the data elements, we can able to go for insertion. For deletion, please understand, for deletion itself, we are seeing the priority. Sir, enduku deletion ke priority chustunaru, inserting priority enduku chudtala. Here, మనం data elements ఎంత fast గా స్టోర్ చేస్తున్నాం అనేది కన్సర్న్ కాదమ్మా. How fast you can able to access. For example, you are using Google search. Okay, you can able to go for any MNS search. Okay, any type of searching tool on the browser. Okay, we will not concern how much of time it takes to load data in the particular server. Okay, how much of time it will take to access the data from the server is the most important thing. Google search use చేసినప్పుడు మీరు చూడండి, if you search any word in the Google search, at the below of that search tool, they will display you how much of time it will take to access the data from the server and display to the user. ఎంత ఫాస్ట్ గా సెర్చ్ ఆపరేషన్ జరిగింది అక్కడ మిల్లీ సెకండ్స్ తో సహా ఇస్తాడు. 0.00012 milliseconds. Okay, why they given the time? The time they given there is searching time, accessing time. Okay, so how much of time it will take to insert is not a big one. Okay, how much of time it takes to access the data is the concern thing. అంతే కదా, మనకి ఎంత ఫాస్ట్గా డేటా వస్తుందో మన యాక్షన్స్ అంత ఫాస్ట్గా కంప్లీట్ అవుతాయి. అవర్ టాస్క్స్ విల్ బి కంప్లీటెడ్. So in order to keep that mind, okay, the real time example, okay, the priority queue is designed and the priority is being given for the data values at the time of accessing or at the time of removing or at the time of deleting. Okay, sir, for example, if all the data elements are arrived at the same time, the A, B, C, D, అన్నీ కూడా ఒకే టైంకి అరైవ్ అయ్యింది. Okay, they may be arrived at first hour, for example. Okay, then which element I have to be insert? Then you can able to see the priority number for insertion also. ఇక్కడ చూడండి, data element A is there, data element B is there, C, D, and every value have the priority number. Okay, based on the priority you can able to delete. Okay, for example, if all the elements A, B, C, D are all the elements are arrived at the same time, then which element have to be inserted first? Then you can able to see the priority number. Then you can able to see the priority number. For example, A, B, C, D, all the values are arrived at the same time. Then you can able to go for identify the priority. Okay, the priority D have the highest priority. So first we are going to insert D. Next element is C. So C has to be inserted next based on the priority. Next one is B. So B is the next priority. So we have to insert B. Next one is A. Okay, so now where is it A? After inserting at the index 3. Okay, where is it? Okay, so that is about priority queue. Every data element have their priority. Okay, based on the priority only we will be able to perform the operations. Okay, DQ definitely will depends upon priority. NQ based on the arrival of data elements we will insert. If all the data elements are arrived at the same time, then we will see the priority. Okay, actual points are there. Okay, what are the points till now we discussed? They given here. See, in the priority queue, insertion is performed in the order of their arrival, and deletion is performed based on the priority. Okay, so this is about the priority. Okay, priority. Sir, what is the advantages and disadvantages of priority, and how you represent the priority? Priority queue you can able to represent using an array or using a linked list also. Same as it is how we are going to see representation of a normal queue and representation of a circular queue using array and using linked list. The same thing also. Okay, for this subject, no need to discuss all the insertion and deletion operations, because introduction itself is enough for your data structure subject. Okay, and the most important thing is what is the advantage and what is the disadvantages of priority queue. Okay, they may ask you, even though you have the circular queue, why you are going for the priority? Nothing but advantage. Okay, here the priority queue we are going to perform accessing or deleting or removing based on the priority, and then user requirement batti మన actions perform చేస్తాం. Okay, at the time of inserting the data element, okay, user given some priority for the data. So based on the requirement of user only, we are going to give the priority, and based on the priority only, we are accessing the data. So everything is related to user requirement. Okay, so that the accessing time for the data element is minimized and fast way accessible. That is the advantage of priority queue. If normal linear queue lo gaani circular queue lo gaani chudandi, the incrementing of front and rear is in sequential. For example, మీ దగ్గర 100 size of the array, size of the queue is 100, 0 to 99 data elements ఉన్నాయి. Okay, according to the user requirement, you need to delete an element which is there at 98th position. Now please listen my words carefully. ఇప్పుడు యూజర్ రిక్వైర్మెంట్ ప్రకారం ఒక డేటా ఎలిమెంట్ మనం డిలీట్ చేయాలి. అది ఎక్కడ ఉందంటే 98th పొజిషన్ దగ్గర ఉంది. ఓకే, దెన్ వాట్ వీ హ్యావ్ టు డూ? We are going to start the front pointer variable from 0 to 1 to 3 to 4 to 5 and so on will reach until 98. Okay, means 97 comparisons are need to be performed in order to delete the 98th element. 98th element delete చేయాలంటే 97 ఎలిమెంట్స్ అన్ని డిలీట్ చేసుకుంటూ వెళ్తేనే 98 డిలీట్ అవుతుంది. డిలీట్ చేయడం ప్రాబ్లం కాదమ్మా. ఓకే, in order to perform deletion it is not a problem, but these 97 index values you need to be traverse, just like linear search. Linear search లో కూడా మనం ఇదే కదా చేసింది. Why? because the user given element is there at 98. Okay, but if you go for the priority queue, at the time of inserting the data elements also, if you follow the priority, and the highest priority element first insert cheyadam, next element next insert cheyadam, ala ganaka chesarante, okay, if you done base insertion based on the priority, then accessing is also based on the priority. So మనం access చేసే element first లోనే ఉంటుంది కదా, because the user given the priority. So highest data element first insert చేసాం అనుకో, so the first element what we are going to be delete is the highest priority element. Means the time taken to access the data element in the priority queue is very much minimized. Okay, so that is the advantage of priority queue. Okay, ఇప్పుడు అన్ని data elements same time లోనే వచ్చినాయి. Okay, all the data elements are arrived at the same time. Then we will see the priority number of every data element. Based on the priority, we make insertion, means we make enqueue operation. Okay, very good. Now, again, we are going to access. Okay, based on priority only we will access. So, highest priority element ekkada untadi? Index 0 lo untadi. And then at the first shot, we can able to take the first element from the first index value. No need to traverse. Then user required second priority element. It is there at the second index value. In one comparison, we will go for the second index. There you can able to retrieve and you can able to give the user. Okay. So now please, I am requesting everyone, please write what is the advantage of having priority queue. Okay. Based on the priority only, we can able to access the data elements. Okay, and in order to access the data element required by the user, it takes the minimum amount of time. Okay, so this is about advantage of priority queue. Can anyone say what is the disadvantage of priority queue? Anyone in the class? Till now we discuss about advantage. Okay, based on the priority, you can able to go for fulfill the user requirement. User ki ఏది కావాలో ఆ ఎలిమెంట్ డిలీట్ చేస్తాం, ఏది కావాలో అది ఇన్సర్ట్ చేస్తాం. Because every element is being given with a priority number. Okay, can anyone say what is the drawback? Anyone in the class? 79 Jahnavi, 81 Jagadish, 87 85 Pooja, anyone in the class? 91 Harish, sorry, Kishore. 91 Kishore is there?
Yes, sir.
But can you say what is the drawback of priority queue? Just simply observe what is priority queue, what we are doing. So in order to implement the concept of priority queue using an array or using a linked list, okay, have you feel any overhead? That will be acts as a disadvantage of priority. Can anyone say what is the priority queue disadvantage? మీరు ఆలోచిస్తే మీకే వచ్చిందండి డిసడ్వాంటేజ్ ఏంటో. Think for 2 minutes and say. Anyone in the class? Here we are giving the priority. Based on the priority only we are inserting and deleting. Okay. So you can able to fulfill the requirement of user within a fraction of seconds. Okay. So accessing time is very much minimized. That is the advantage. Okay. Then what is the drawback? What is the disadvantage? Okay, I will explain. So see here, for example, if you represent the priority queue using a linked list, okay, then what is the structure of a node? Generally, in the normal queue or the circular queue, we are taking the structure is like a single linked list. So it may be the two fields. One is the data part, okay, and one is the address part. Okay. One is the data part and one is the address part. Similarly, if you want to implement the priority queue using the same single linked list, okay, but the structure of the node what we are considering till now is not enough for the priority queue. For example, data element A వచ్చింది. So what we are going to do till now in the normal queue, we are taking a node and we are taking the data is A. Okay, initially it address part we are taking as null. Okay, similarly if you have one more data B, so for the B also we can able to create the node containing two fields. The data part is filled with B. Okay, and we are making its address part is null. As B arrived after A, okay, we are making a connection from A to B. So what we are going to do? Simply we are making an arrow from A to B. So it may be a normal queue or it may be a circular queue also. But here, if you see in the priority queue, every data element, okay, not only contains data value, but also contain a priority number. Ante structure of a node, this is not enough to represent a data element as a node in the priority queue. Please listen my words carefully. This structure of a node is not enough. It is not enough to represent the address. Okay, we need to represent the priority of the data element also. Prati data element ki kuda oka priority number undi. Ikkada nenu Rajesh chupichanu. This 5, 3, 2, 1. Those are nothing but priority numbers given for the data values. So, మనం linked list represent చేసిన array లో represent చేసిన data element తో పాటు దాని యొక్క priority number కూడా represent చేయాలి. Okay, so here the structure of a node while implementing the priority queue using linked list should contain 3 fields. Okay, one is the priority for the data element, priority. Okay, and one is its original data, and one is the address. So that is the structure given. That is the structure given for every data element. What we are going to be get, and what we are going to be insert, or what we are going to be delete from the priority queue. And then node A. Okay, data element is A. Okay, identify what is the priority. We already తీసుకున్నాం an example. Priority for A is being given as 5, so that has to be given. Okay, and what is the priority given for B is 3, so that has to be given. Okay, so the structure of a node in the priority queue while you are representing as a linked list should contain 3 fields. One is the priority, one is the data, one is the address of an next node. Okay, sir, structure of a node ki disadvantage of priority queue ki sambandham enti? Sambandham entante, if you are taking 3 fields in the node structure, then obviously the memory requirement for the node is also more. అంతే కదా, ఒకటేమో priority స్టోర్ చేయాలి, ఒకటి డేటా ఎలిమెంట్ స్టోర్ చేయాలి, ఒకటి అడ్రస్ ఫీల్డ్ స్టోర్ చేయాలి. ఈ మూడు కూడా ఒక నోడ్ లో స్టోర్ చేయాలి. అంటే నోడ్ కి ఎంత మెమరీ కావాలి? కంపారిటివ్లీ మోర్ మెమరీ ఇస్ బీన్ రిక్వైర్డ్. అదే సింగిల్ లింక్ లిస్ట్ లో అయితే స్ట్రక్చర్ ఆఫ్ నోడ్ 2 ఉంటాయి. ఒకటి అడ్రస్ పార్ట్, ఒకటి డేటా పార్ట్, ఒకటి అడ్రస్ పార్ట్. సో 2 ఫీల్డ్స్ ఉన్నాయి కాబట్టి దానికి మెమరీ తక్కువ కావాలి. బట్ హియర్ data element ఎంత సైజు ఉంటుందో అంత సైజు కావాలి. With addition to that, whatever the priority number we are giving, for that also memory is being required. Hence more memory is being required to create a node in the priority queue comparative to circular queue or normal queue. Okay, so that is the drawback of priority queue. అసలు యాక్చువల్గా డ్రాబ్యాక్ డిసడ్వాంటేజ్ అనవమ్మా. ఎందుకంటే మనం యూజర్ రిక్వైర్మెంట్ని ఫుల్ఫిల్ చేస్తాం. యూజర్కి ఏ డేటా కావాలో ఆ డేటా ఎక్కడ ఉంటే దానికి ప్రయారిటీ ఎక్కువ ఉంటే దాన్ని రిట్రీవ్ చేస్తాం. ఫుల్లీ డిపెండ్స్ అపాన్ యూజర్ రిక్వైర్మెంట్. బట్ ఇన్ ద ప్రాసెస్, ఇన్ ద వే ఆఫ్ ఫుల్ఫిల్లింగ్ ద యూజర్ రిక్వైర్మెంట్, వీఆర్ టేకింగ్ ద మోర్ అమౌంట్ ఆఫ్ మెమరీ ఫ్రమ్ ద ఆపరేటింగ్ సిస్టమ్. హెన్స్ వీఆర్ ట్రీటింగ్ దట్ యాజ్ ఎ డిసడ్వాంటేజ్. Okay. Advantage is based on the user requirement, the accessing can able to do. Accessing can able to takes very less amount of time in the priority queue. But at the time you are representing priority queue using a linked list or using an array also. Using an array also. Okay, the more amount of memory is being required because, please write in your notes, because with addition to the data element, the priority for the every data element is also be stored. So, structure of a node, 3 fields this one. One is the data, original data, one is the priority given for the data, and one is obviously the address. Okay, so we are treating that as a disadvantage of priority queue. Okay, so all these about priority queue. I hope everyone understand about its advantages and advantages for the priority queue. Anyone have any doubts? Please let me know. If you clear about priority queue, then I can go for the next one, last type. Anyone please respond. Anyone have any doubts? Or else if you clear or not, please let me know now.
Clear, sir.
Clear, sir.
Okay. Now already I given unit 3 lecture notes also. Okay. In that you can able to refer the points. Okay. After this class you can able to see the lecture notes, what they given about priority queue. Okay. Operations in priority queue is not mandatory for the data structures subject for this semester. Okay. Okay. Next we will go for one more, last one in the types of a queue is about BQ. Okay, here BQ means you may feel that it is a deletion operation in the queue. Okay, names are same, but BQ is an abbreviated word. Okay, it is given as double-ended queue. Okay, double-ended queue. So, mere queue starting up, queue is a two-ended queue అని చెప్పారు. Then what is the difference that normal queue and the DQ? ఇక్కడ మీరు చూడండి, నార్మల్ క్యూస్ లో మనం 2 ends ఓపెన్ అని చెప్పిన ఫ్రంట్ అండ్ రేర్ దే హ్యాస్ టు బి స్టార్ట్ ఫ్రమ్ ఇండెక్స్ 0 అండ్ దే హ్యావ్ టు ఎండ్ విత్ n-1. ఒక డైరెక్షన్ లోనే మనం ఇన్సర్ట్ చేయగలం, ఒక డైరెక్షన్ లోనే డిలీట్ చేయగలం. స్టార్ట్ ఫ్రమ్ 0 to n-1. Okay, if it is a circular queue, again after reaching the n-1 index location you can jump back to the index 0. You can jump back to the index 0. And one direction again 0 నుంచి n-1 వచ్చారు, మళ్ళీ n-1 నుంచి 0 నుంచి స్టార్ట్ చేస్తున్నారు. Okay, so either it may be a normal queue or it may be a circular queue or it may be a priority queue also. Okay, conceptually we are treating that queue is a two-end open, but the front and rear pointer variables they have to start from initially -1. Okay, then they are incremented to 0, 1, 2, 3 and so on. Okay, but here in the double-ended queue, what we are going to do is we can able to perform both insertion and deletion operations in both end. And the insertion and deletion itwait cheyochu. We can able to perform insertion and deletion at this side, or we can able to perform insertion and deletion at this side. Okay, means the front and rear you can able to start from at index 0. Okay, and the front and rear you can able to start at index n-1. Start 0 నుంచి స్టార్ట్ చేస్తే 1, 2, 3 ఇలాగే వెళ్ళాలా? లేదు. Okay, you can able to again go for n-1. At that side also you can able to insert. Okay, in that direction also you can able to insert. Okay, both front and rear parallelly. Okay, both front and rear parallelly can able to perform the operations of NQ and DQ, means insertion and deletion at the two ends of the queue. Okay, so DQ is the actual implementation of queues concept. Okay, so in order to represent this DQ, okay, we can able to go for arrays, or we can able to go for linked list also. But please remember this point, no? It is very familiar and very easy, okay, to use linked list. ఎందుకంటే లింక్డ్ లిస్ట్ లో చూడండి, this node it is dynamically stored. This second node it is dynamically stored wherever we have the free space. Third one dynamically. Fourth one dynamically. Wherever we have the free space, there all these nodes are stored. అవునా? సో ఇన్సర్షన్ డిలీషన్ అనేది మనకి లింక్డ్ లిస్ట్ ప్రెజెంటేషన్ లో ఎక్కడైనా చేసుకోవచ్చు, అంతే కదా. యూ కెన్ ఏబుల్ టు ఇన్సర్ట్ ద నోడ్ ఎట్ ద ఫ్రంట్ ఎండ్ ఆఫ్ ద లింక్డ్ లిస్ట్, మీన్స్ స్టార్టింగ్ ఆఫ్ ఎ లింక్డ్ లిస్ట్. You can able to delete the insert at the end of a linked list, or you can able to select any one node at the middle of the linked list that can able to delete. Okay, so 3 type of deletions in linked list. Okay, similarly 3 types of insertions in the linked list. So it is advisable to implement the concept of DQs by using linked list. అదే అరే తీసుకున్నారనుకో, ద పాయింట్ ఫ్రంట్ అండ్ రేర్ నీడ్ టు బి జంప్ ఫ్రమ్ వన్ లొకేషన్ టు అనదర్ లొకేషన్. ఓకే, ఇట్ మే నాట్ బి పాసిబుల్, అంతే కదా. ఇప్పుడు సింపుల్ అరే తీసుకున్నాం, ఫర్ ఎగ్జాంపుల్ లెట్ us take this array. Okay, takes some index 0, 1, 2, 3 and 4. Okay, according to the DQ data structure, okay, the front and rear both may be at start from index 0, both may be at starts from index n-1, means it may starts at index 4. ఒక వాల్యూ ఇటు ఇన్సర్ట్ చేసి ఒక వాల్యూ ఇటు ఇన్సర్ట్ చేసుకోవచ్చు, ఒక వాల్యూ ఇటు డిలీట్ చేసి ఒక వాల్యూ ఇటు డిలీట్ చేసుకోవచ్చు. 2 ends open, you can able to perform both insertion and deletion at the both ends of a queue. అప్పుడు మీరు అరే రిప్రజెంటేషన్ చేశారనుకో, we need to make a movement of front pointer variable from one location to another location. Okay, for writing program also, for array representation of a queue, it is not easy. That's why in most of the textbooks, okay, in the most of the textbooks, this DQ will be implemented by using the linked list only. Okay, because the linked list you can able to store the data randomly in a dynamic way. Okay, we can able to insert the node at the front end, you can able to insert the node at the tail end, at the last one. You can able to insert in between of any 2 nodes. Okay, that's why we are going to implement the DQ concept using the linked list only. Some textbooks are even in the lecture notes also, I may give in array also. Okay, but movement of front and rear from the both directions now. When you choose the 1 second, if you see here, front and rear ikkada తీసుకుంటాం, front and rear ikkada తీసుకుంటాం. Okay, in both ways the front and rear can able to jump. Okay, but as you represent that DQ using an array, it leads to confusion and the program is also very large, very bigger one. Okay, so it is suggestible to take the linked list. Okay, the structure of a node is also same, because it contain only 2 things, one is the data part, one is the address part. Nothing more than that. Okay, so this is about double-ended queue, DQ. Now, కొన్ని టెక్స్ట్ బుక్స్ లో DQ అంటే ఇలాగే రాస్తారన్నమాట, DQ ఇంతే. Okay, DQ is nothing but double-ended queue, abbreviated. Okay, DQ అని కంప్లీట్ గా రాశారు అంటే, if they ask you to explain what is the DQ operation అని క్వశ్చన్ లో మెన్షన్ చేస్తే, mandatorily you need to consider this is the deletion operation. Okay, the same word of రెండింటికి DQ an operation అని అన్నారంటే, then you can able to take a normal linear queue or you can able to take a circular queue and perform deletion operation. Okay, if they given like DQ data structure, then you can able to consider that as double-ended Q. Or sometimes in some textbooks they given like this, DEQ. DEQ. It is a abbreviated word. See here, D double E ended Q means it is Q. Okay, so exam law, either it may be a mid or it may be a semester. If they ask you about DQ operation, then please remember that they are asking you to perform deletion. Okay? Okay, if they given like data structure of DQ, explain about the DQ data structure, or if they given the abbreviated like this, DEQ, then they ask you to perform what is meant by double-ended. Okay? Okay? Chala types కూడా ఉన్నాయి, but according to the syllabus, okay, it is enough to you. Okay, and the last one is there. ఇవన్నీ ఎందుకు నేను ఆపరేషన్స్ ఎక్స్ప్లెయిన్ చేయట్లేదు అంటే 99% they will not ask you in the data structure subject, because all these concepts are advanced data structures concept. Okay, 1 second. Okay. Hope you can able to see my screen. 1 second. Okay. So that is about DQ introduction. So now this is the actual figure they given for DQ. Okay, undaniki front and rear okkasari kamartayam, but the front and rear you can able to use from both the directions. So you can able to perform insertion and deletion at this end, starts from 0. Okay, or else you can able to perform the insertion and deletion at the this end also. Okay, and what are the operations we are going to be performed? Okay, the operations you can able to take push, pop, inject, eject. Again, push, pop, inject, eject, those are exactly similar to NQ and DQ. Push and inject. Okay, these two. Push and inject. These two. Okay, they are trying to insert the data element onto the DQ. Double-ended Q. Similarly, pop and eject. Actually, push, pop, so pop and eject. Okay, they are used to delete the data element on either ends. Either it may be at this end or they may be at this end. Based on the user given element, you can able to perform deletion. Okay, push, pop and మాత్రం యూజ్ చేయొద్దమ్మా, ఎందుకంటే మనకి నెక్స్ట్ స్టాక్ డేటా స్ట్రక్చర్ వస్తుంది, అక్కడ మనం ఈ పుష్ పాప్ అని యూజ్ చేయాలి. Okay, so in this DQ you can able to go for inject, is nothing but inserting the item at rear end of the queue, rear end of the DQ, and the rear pointer variable ekkada unte akkada, either it may be from 0 to n-1 or from n-1 to 0. Okay, for inserting the data item we are depends upon rear, as you already know this. Similarly, eject, deleting. For deleting means for removing the data element. Okay, we are going to depends upon front, not rear. For front end, the front end can able to perform both in this direction or at this direction. Okay, so that is about types of a queue. Okay, so this is the end of first part of the queues data structure. Okay, okay, next class we will start stack data structure. Okay, second part of the unit 3 is about stacks. Okay, in the meantime you can able to ask if you have any doubts, and I asked you to submit class test 3 ma. Okay, class test 3 ఎంతమంది సబ్మిట్ చేశారండి? Some are they are sending in my WhatsApp. Okay, 54 members are submitted. Very good. Remaining students, those are not submitted class test 3, please submit before 11:30. Okay, because I have to upload the marks in CAS and I have to take the print, I need to submit. Okay. So before that, submit. Your attendance, ma'am. 68. 68 absent. 76. 76 is there absent. 87 absent. 95, 97, 98, A naught. But these students are there, please respond. A naught, A9, B4, B8, B8, C0, C1, C7, C7. C7 is there. Okay. These numbers are considered as absent, ma. Anyone have any doubts? Anyone please respond. Anyone have any doubts? So today what we discussed? We discussed about two types of a queue. One is priority queue and one is the D queue. Okay, that ends the queues concept in the third unit. Anyone have any doubts? You can able to ask, or else you can leave and take the break. We have a fourth hour. In the fourth hour, we will start stacks. Stack data structure. Very simple and easily scored concept in the data structure subject. Okay. We will meet again in the fourth hour. Thank you everyone.